If you visited anywhere across most of North America in the spring or fall, you've most likely heard some most persistent chirping. This chirping is the song of the fall field cricket, and you'll find the males singing from the entrances of their little burrows or cracks in the ground, chirping their little hearts out in the hopes of attracting a mate. But how do they manage to sing their little love song? If you think that they sing by rubbing their legs together, you'd be wrong, but it's a very common misconception. Crickets have microscopic wrinkles on the underside of their wings, and these are called a file. And they actually chirp by raising their wings to a 45-degree angle and rubbing the scraper part of one wing against the file of the other wing. Something like when you run your fingers along the teeth of a comb. It's a process called stridulation, and here's a closer look. You want another fun fact? Did you know that you can tell the temperature outside by a cricket's chirp? That's right, you can! To get a rough estimate in Fahrenheit, you count the number of chirp bursts in a 15-second period and then add 37 to that. Let's try it. Here's the historical temperature readings during the date and time of the filming of this video. So the temperature was around 72 to 73 degrees Fahrenheit. Okay, now let's count the chirps. So in this clip, I counted around 38 chirps, which was pretty average during my filming. So if you add 37 to that, we get 75. Wow, that was pretty darn close. But crickets are so much more useful than just as a thermometer. Cricket research is starting to evolve from use in very basic research projects to much more complicated topics, such as brain function, behavioral studies, and even biological clock studies. All of the developmental stages of the cricket have proved to work for observed detailed morphology, behavior, and even gene expression. And bonus, they can even regenerate damaged body parts like their legs. Crickets are an especially hot topic right now as they are being looked at as a viable, sustainable food source. A high-protein, low-carb flour alternative. But it takes about 5,000 crickets to make just 1 pound of the flour. Still, the possibilities of fascinating research projects involving crickets seems endless right now. And crickets are even starting to compete with zebrafish as viable research subjects. So, just how adventurous is your palate? Would you eat crickets or something made from cricket flour? We'd love to hear your answer in the comments, so let us know. Do you know any students interested in participating in science fairs, student research, or publications? Be sure to check out our Student Research Academy at thecuriocat.com.